The Pennsylvania State University, College of Earth and Mineral Sciences, Department of Energy and Mineral Engineering presents Solution Preparation, Molarity, Molality, and Gas Blankets. Equipment and Materials. To make solutions, you will need a squirt bottle, a spare beaker, a spatula, a funnel, weighing paper, a volumetric flask for molar solutions, and any vessel for mixing for molal solutions, a graduated cylinder, and an analytical balance. Experimental procedure. Making solutions on a molal scale. To weigh the water, place the spare beaker on the balance and press tare. Make a coarse estimate of the required mass. Using the squirt bottle, make a more exact estimate. If too much water is added, use a separate beaker and pipette to adjust the mass until the desired mass is met. With the solute and solvent weighed out, place the denser of the two components in the mixing vessel first. Then rinse the residue off the sides of the funnel with the second component. There are two acceptable ways to mix the components. The first is vortexing. The second is inversion. Experimental procedure. Making solutions on a molar scale. To make molar solutions, you first need to add the solute to the volumetric flask. Using a squirt bottle, rinse the residual solute off the funnel with the solvent. Next, use a graduated cylinder or beaker to add enough solvent to raise the solution volume to the base of the neck. Mix using the vortexing or the inversion method. Taking the squirt bottle, add solvent to the etched line on the volumetric flask. When the volumetric flask is full, vortexing is not an acceptable method of mixing, and therefore the inversion method must be used. Experimental procedure, gas blankets, and deaeration. Make sure the needle valve is closed, the regulator spring is not engaged, and the cylinder valve is closed. Both gauges should be zeroed. Open the cylinder valve until the high pressure gauge is steady. The valve should be opened completely. Next, turn the regulator spring pressure dial until the low pressure gauge reads the desired pressure. This may take several turns depending on the regulator. The needle valve should remain closed. If the pressure is over the desired pressure, open the needle valve, then turn back the spring dial until the pressure is that which is desired. Remember to close the needle valve when you are finished adjusting the pressure. Turning back the dial will not reduce the pressure when the needle valve is closed. Also, make sure that the tubing from the regulator is vented to a fume hood during this process. Slowly open the needle valve to start the flow of gas to the system, making sure the cell is connected to the regulator. To ensure there is a positive pressure in the cell, bubble the excess gas from the cell through a separate beaker filled with water. This will ensure that any leaks will be internal gases escaping and not atmosphere leaking in. Immerse a sparger in the desired solution for several minutes to deaerate the solution. With the tubing disconnected from the system, close the cylinder valve. Then, open the needle valve to depressurize the regulator. Note that the high pressure gauge will drop first, then the low pressure gauge. When both gauges read 0, relieve all pressure on the regulator spring by turning the regulator spring dial.